Friends, a very good morning to one and all. Today we will discuss about limit and limit point of a sequence. Now we will discuss about limit point of a sequence. A number t is said to be limit point of sequence an if every neighborhood of p contains infinitely many terms of sequence an. Let an be a sequence of real numbers and p be real number if there exists a neighborhood of p which contains only finite terms of sequence, then p is not a limit point of sequence. Now let's take an example of sequence minus 1 power n, which is equal to sequence minus 1 1 minus 1 1 minus 1 1 and so on. Its range set is minus 1 1. Therefore minus 1 and 1 are its limit point. There is a result which says that elements of range set of oscillating sequence are its limit point. Now we will discuss about limit of a sequence. Let an be a sequence and L belongs to R is said to be limit of sequence for if each f not greater than 0, then there exists m belongs to n such that modulus of an minus L less than f naught for all n greater than equal to m. Limit of a sequence is given by limit n tends to infinity an. Now we will discuss about difference between limit and limit point of a sequence. In case of limits, the number of terms that lies inside the interval L minus f naught, L plus f naught must be infinite, and the number of terms lie outside this interval must be finite. Whereas in case of limit point, the number of terms lie inside the interval L minus f naught, L plus f naught must be infinite, and there is no condition on the number of terms that lie outside this sequence. Now we will learn about Bolzano-Weierstrass theorem, which says that every bounded sequence has a limit point. Let's take an example. Sequence of 1 plus minus 1 power n, which is equal to sequence of 0 2 0 2 0 2 and so on. Clearly its range set is 0 and 2. Therefore 0 and 2 are its limit point. Now we will learn some results. An unbounded sequence may have a limit point, but the converse may not be true. I take example of sequence an, which says that 2, which is 2 if n is prime, and n the number itself if n is not prime, and the sequence will be 1 2 4 2 6 2 8 9 10 and so on. Its limit point is 2. A sequence can have at most one limit. Unbounded sequence cannot have any limit. A non-monotonic sequence can have limit. Example, sequence of an is equal to sequence minus 1 n upon n is equal to limit minus 1 n divided by n is equal to 0. Therefore limit exists which is 0. Therefore it is clear a non-monotonic sequence can have limit. A bounded sequence may not have limit. Take example of sequence minus 1 power n. Limit. Its limit does not exist, but it has limit point. If the limit point of a sequence is unique and the sequence is bounded, then the limit point is the limit of sequence. If the limit point of a sequence are more than one, then the sequence cannot have limit. Limit of a sequence is also a limit point, but converse need not be true. Now let's discuss a question. The sequence Sn is equal to 2 when n is even and lower prime factor of the number when n is odd has limit point. We are given with 4 options. Option 1 is 2. Option 2 is 1 2 3 4 5 and option 3 is countable in number and option 4 is uncountable in number. we will find the range set of the given sequence. 1, 2, 3, 2, 5, 2, 7, 2, 3 into 3 is equal to 3, which is lower factor of prime. Two, 11, 2, 13, 2, lower prime factor of the number, which is 3. In place of 18 we will write 2. 19, 2, 3 into 7, which is lower prime factor is 3. We will write 3 in place of 21. 2, in place of 24, which is even, we will write 2, and in place of 25 we will write 5 into 5, which is 5. 5 is lower prime factor of the number 25. Clearly, the limit point is countable in number. Therefore, the correct option will be C, countable in number. Thank you and have a nice day.